¿Sí? Hola. Bueno, pues vamos a continuar con...
Welcome back. Let's resume today's conference. Since we're running late of time, we're going to give the floor to our first speaker. We have Nacho Brodin, who is a developer at ProDevelop and is a member of the gvSIG Association. He is a specialist in Raster. He is also known as Mr. Raster. He didn't know I was going to mention this, so that's why he's showing a strange face. All right, Nacho, so you have the floor. Good morning. Through my presentation, I'd like to tell you a little bit about Raster in gvSIG. So this title, Improving Raster Data Treatment and Visualization in gvSIG version 2.0, is a bit fancy. I'll just try to make this as simple as possible. There's been an evolution that has depended on numerous contributions. So we make headway thanks to the contribution of individuals. Here you see contributions made this year and last year. There's been an improvement of the stabilization process. In time, we not only solve bugs, but there are some flaws in the different tools, and we try to solve this. There's been contribution by España Virtual, Virtual Spain. We'll mention this in some more detail in a minute. Then another contribution would be that of Project Enagdes. We also have the sensor project, Proyecto de Sensores. It has been mentioned this morning, and then there are other contributions like that of Code Sprint and specific contributions by individuals. So there's not one single path, but many people walking together in one direction. So there's been structural changes, modifications to adapt to version 2.0 of gvSIG. There's been adaptations, especially in the core. Since the core changed, everything around it had to be adapted also. Modularity has been attained thanks to the plugin installer. I'll mention a little bit more about this in a little while. There's been a layer tiling, and this is quite interesting. This is the screenshot of the plugin installer. You see the roster and extensions. You can select the platform and some platform-depending plugins. You can define whether you want to use Windows or Linux. As regards functional novelties, I would like to show you a clip so that you can wake up in case you're drowsing off. There's reprojection. There's been improvement of existing tools like Info by Point and ROIs. There are new services like OSM, OpenStreetMap layers, and I'll show you a clip in a second. We've seen WMTS, PostGIS, Raster, and other tools like vectorization. Vectorization is interesting. I have performed a little benchmark, some comparisons, and I've produced a report on the subject. And if I have time, I'll also touch upon time information. As for reprojection, we had problems in the previous version. It was a tool that was not really usable, so it required improvement. The problem with the reprojection was that it's done through GDAL. It's a native code, and GDAL is not written in Java, and this poses memory management problems. So sometimes there's a problem with gvSIG libraries. There's also incompatibility among gvSIG projections. GDAL has other projections. So there could be incompatibility between both. There was a memory management problem, and it does not allow for transformation of files. So let me show you the new tool. We have a raster layer in 23030. You see the view here is different. So we load the same vector layer in 4326, the correct layer, with the grid, and I will show you the user interface, which is the actual novelty. See, this is the vectorial layer. You see both things match, and let's reproject the raster. This is the novelty. This is a new interface. You can select the input projection and the output projection, the origin and destination projections. We can interpolate. There's a resampling, so we can interpolate. There are several methods, and we can select the output size. By default, you have the optimal size. It calculates the height and the width. You cannot change image proportion. So when we implement the process, I've stopped it because the image is quite large, so it would take several minutes to process. But when the process is completed, we can see the layer. You have the typical frame of reprojected images because, of course, there is no perfect matching with the output box. We see this little defect. So we apply a grid to the vectorial layer. You don't do that for the raster. So you reproject, apply the grid, and we have a reprojection that has gained as regards data volume. We can reproject this and place very accurately. These progress bars, some say, well, it seems to crash a little, but you really don't have to pay much attention to that. It might show 99% completed, and you might have to wait a little bit more than expected, but that shouldn't be a problem. It definitely works. You have some statistics. you see that both things match. This was it's only logical that both projections matched because it's a video clip. I'm not doing this live, so of course I chose something that worked. As for regions of interest, this is a tool that was not as usable in the previous region. As you know, these regions of interest are sort of polygons that you can use within the B box. Back in the day, or with the previous version, we had to draw these, so it's better to import the layers and say, okay, I want this layer to be my region of interest. So we've modified this tool, and you can now use a vectorial layer that you've loaded and import it. And it uses the available area in the raster layer, and you can attach this layer. As for the information per point tool, let me show you the clip. It's simply an improvement. The information per point in gvSIG was very vector oriented, and it's good because it's quite accurate, and you get real-time information. You have a view box and shows you a proportion. You can magnify times 4 times 6. You get real-time data as you move the cursor around. Sometimes it's very pixeled because I'm moving the mouse quite quickly. And what you see on the top left depends on the zoom percentage of the actual larger view. Let us move on. Another structural improvement would be the local Tessels cache for raster services. I don't have a clip, nor of the WMTS client, because you all know this about this, but the local Tessels are stored by resolution levels. It can be used for tesseled services for WMTS or for OpenStreetMap, OSM. And when you load a layer on gvSIG, it now asks, do you want to tessel? We tend to click OK, 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 but we need to know what we're doing here, because this actually fills up our hard drives. So this is tessellating and storing in a local drive. So here we see some clients that make the most of the Tessel cache. We have a post GIS Raster client. We've heard about this, and there's been some headway. We've integrated on gvSIG 2.0. It accesses post GIS in its version 2.0. There was VT Raster. It ran over on PostGIS. But now with version 2.0, you have the full server. There were some incompatibilities, and some adaptation has been needed, but it now works. It has not been too tested, because it's quite recent, so we need to run more tests. We've used the test servers to test it. We'll see. As for the OpenStreetMap client, this is this little extension which allows to see the cartography on gvSIG and has a basic access to cartography in the view. I spoke to Ivan Sanchez last year about this, and we said, well, we could we could improve this, and we've been developing this over time. And as you can see, there is well, you will see there is a menu. You can add layers. Do you want to see it? Okay, I'll show you so you know what we're talking about. The OMS is supported by JRS. This is a solvable problem with Juan Peña Rubio. We discussed how this could be solved for once and for all. So here what we're actually doing is to load the spat reference, the VKT chain or string. You copy and paste, and the string works wonderfully. So we would have the view in the intended projection. This is the menu I mentioned. This is the OMS layers. So we want to improve this by allowing users to define new servers, change servers, because some have different URLs. So right now there's this fixed menu, but it will change in short. So you select one and you access the cartography. See that what we just saw was not cached. So these servers are excellent. So let us superimpose this with a cadastral layer, because the cadaster has this projection. We have to see if it all matches. We select the WMS layer, and there you go. It's loaded. We change the OpenStreetMap layer. We see that they match wonderfully. For the same reason, it's a clip. And I've mentioned a little bit about WMTS client and net CDF support. I don't have time to show you more. I want to finish by telling you a little bit about temporal data. It doesn't have much to do with the rasters, but since I have a minute left, I'll tell you the story. There's an animation extension that was the temporal part was integrated in gvSIG. By this I mean we can perform queries per time. You can filter on the basis of time in a future raster. So since you can do this, you can easily generate an animation. So that's exactly what this extension does. It generates animations. You select a time window, and you have a step, real-time step. You say, I want to see this amount of data every X time. I have a 3-4 minute clip. I don't have the time though, so thank you very much for your kind attention. Thank you so much, Nacho. I'm sorry we can't give you more time.